Let's talk about an orbital diagram. An orbital diagram is a model showing where those electrons are. So it's very similar to an electron configuration, but it tells us a little bit more information. We use arrows to describe each electron in an element. So let's look at carbon. So with carbon, its electron configuration is 1s2, 2s2, 2p2. But I can't really see that where those electrons are in the p orbitals, because remember they spread out and there's 3 p orbitals. So let's go ahead and draw exactly where those electrons are. So I am going to label the orbital. So 1s, so again, this is an orbital. And in that 1s, I have 2 electrons. The first electron is drawn as an up arrow, and the second electron is drawn as a down arrow. Let's go to the 2s orbital. Again, 2 electrons, one up, one down. Now let's go to the 2p. So now my 2p orbitals, there's 3 of them. And I do need to draw all their orbitals. Whether they have arrows in them or not, you need to draw them. And I have to put 2 electrons in. So I'm going to put 1 electron in the first orbital and 1 electron in the second orbital. This is called Hund's rule, or the bus rule. When you get on a bus, you don't want to share a seat with anyone unless you have to. And you only share a seat if all the seats are taken. So I just put 1 electron in the first orbital and 1 electron in the second orbital. And I know that there's 3 orbitals for a p, because if I count on the periodic table in that p block area, 1, 2, 3, 4, 5, 6. So I take 6 electrons and I can put 2 electrons in an orbital. So I divide by 2. So that tells me there are 3 p orbitals. The very first electron in the orbital will always be an up arrow. And you always fill the lowest energy levels first. It's called the off-bow principle. So I'm always going to put electrons in the 1s orbitals first before the 2s. So let's go through and write some of these orbital diagrams for each of the elements. And it's okay to use the abbreviated electron configuration. So here's chlorine. Chlorine has everything neon has, plus 3s2, 3p5. So I'm just going to do my 3s orbital. And your s orbital, there's only 2 families on the periodic table in that s block. So 2 divided by 2, I only have 1 orbital. So there's my 3s, and then my 3p. Again, that p block, there's 6 electrons. 6 divided by 2, I need to draw 3 orbitals. Let's go ahead and put the electrons in. So I'm going to go up arrow, down arrow. And then let's do our p's. So I'm going to go up, up, up. So 1, 2, 3, 4, 5. Okay. A little note on style. Sometimes it's a pain to draw the arrows, and so they draw little half arrows. And that is perfectly fine. So I could have drawn up, 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 down. So those little half arrows. The other thing that you might see with these is that you can draw them as boxes. So here's my 3p, up, 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 down, down. So you might see that style. And another style that you sometimes see would just be a line. So up, 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 down, down. And sometimes I've even seen it as a circle. So you get lots of style today. So again, 3p. One thing that you always need to do is label the orbital. And then I'm going to put in my arrows. Up, 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 down, down. So these are all correct for that 3p orbital of chlorine. I'm just going to erase things a bit so I can have room for my other ones. And let's go on to vanadium. So vanadium, it is element number 23. So the noble gas configuration would be, it has everything argon has, plus 4s2, 3d, 3d3. So I think this time I'm going to use boxes. Again, you can use whatever style you like. So 4s, and then here's my 3d. And on this, we have 10 divided by 2, so I'm going to have 5 orbitals. All right, let's put in our arrows. So I have 4s, there's 2 of them, so up, down. And then I have to do my 3D. The 3D is just a little bit higher in energy than the 4s, so that's why it comes after the 4s. But we have 3D, 3, so 1, 2, 3. It's important that you draw these that are empty. You still have to draw them whether you fill them or not. So your s orbitals, only 1. Your 3D orbitals, there'll be 5. And your f orbitals, you'll have 7. All right, let's look at ion orbital diagrams. So you're either going to erase an E, so that would mean if it lost an electron, or you're going to add an E. This would be if it gained an electron. And what I mean by an electron, that would be an arrow. So let's look at chlorine. So just normal chlorine has 17 electrons. And so I'm going to add one more. So 18 electrons. So it's copycatting argon. So essentially I'm drawing what argon is. So argon has everything neon has, plus 3s2, 3p6. So I just draw those. So 3s, 3p. I think I'm going to do just the lines this time. So up, down, and this one has 1, 2, 3, 4, 5, 6 completely filled in. So that's how you do the ions. You just add an arrow or get rid of an arrow. Let's look at this next one. So this next one's sodium. So sodium has, I'm going to write the whole thing. Okay, so there's sodium. And if I were to do sodium ion, that means I would just get rid of that last electron. So I would have 1s2, 2s2, 2p6. So let me sketch that. Again, it's important to label these. So here's my 1s, here's my 2s, and here's my 2p. And I'm going to fill these in. So a lot of times with ions, you will see that they're completely filled. And that's because they have 8 valence electrons, so they're all filled in. But that's how you do the ions, and this is how you do orbital diagrams.